8-question, I believe, homework quiz. So let's take a look at some of these options here. Get this out of the way. We're supposed to check off here which one of the statements are true about the normal distribution. About 95% of all data values lie within one standard deviation of the mean. Is that true? No, it should be 68%. So this is not true. Distribution is symmetric with a single peak. That one is true. So we'll click that one. 50% of the data lie at or above the mean. And again, we could draw, right, here's the mean. 50% of the data is either here or above. That is true. The mean, median, and mode are all equal and occur at the center of the distribution, right here where we drew that line. So that one also is true. Data values are spread evenly about the mean. Evenly. Are they really? No, some are spread further, right? There's variation. I'm not quite sure what that's saying. I would say that would be no. We're going to check it. I might be wrong on that, but from what it's saying, are they spread evenly? They are symmetric, but I'm not quite sure. Sometimes these words evenly, I'm not sure. I'm going to leave it off. The graph of the normal distribution is bell-shaped. That is true, with tapering tails that never actually touch the horizontal axis, right? Remember we talked about that. And data values further from the mean are less common than data values closer to the mean. That is true. The further away we get, the less common they are. And again, I'm not even really sure what this one's saying. I could be wrong on it, but let's see. Let's check. And what they tell us for the answer is all these are true. We were right. In fact, we could actually submit the question. Oh, we missed a part. So I think that's the one. Everything else was there. Data values are spread evenly around the mean. Let's try that. Yeah, that's what it likes. Okay. Sometimes we just have to try, right? You can get it wrong. I still don't understand what they mean by evenly. It's not a technically strong word. Anyway, let's keep going to the stuff that I know from here on we're going to do just fine. A class is given an exam. The distribution of scores is normal. The mean is 78. Standard deviation is 9. So those are our two important values. What is the probability that a student's score is less than 75? And they show us here. So we're able to come to our calculator. We just need to go to distributions. This is normal, we were told. So that's a key part. The scores is normal, not binomial. If it was binomial, that's different. Mean is 78, standard deviation of 9. So we put that in. We put in the standard deviation. Less than 75, so part of it is we can look at the notation. X is less than 75. So yes, we've got the less than tool already selected. And we just have to put in our 75. We hit enter and we've got our value right here. Or right over there. And they want 4 decimal places, so we put in 0.3694. And that'll be our 4 decimal places. And again, we could check here. We got the answer right. We could also, you could submit. If you were wrong, you have another try to submit it. Question 3. A class is given an exam. The distribution of the scores is normal. The mean is 74. Standard deviation 7. Determine the test score C. So now we're not given the test score. We're given a percentage, a probability, such that the probability of the student having that score is greater than 64. So when we put this in, we're going to look at that. We'll change, first thing we do is we go back. We're going to change the mean to the 74, standard deviation to 7. 74, 7. And now we want x greater than. Notice this is x less than. So we come over here. We choose this one, x greater than this value. But we don't put the value here. We put the value over here. It's the answer, 0.64%. Right? And we hit execute. That's telling us that the score of 71, one decimal place, 71.5. Okay, and we see that right there. So having a score greater than this is that. So 71.5. There we go. The patient recovery time for a particular surgical procedure is normally distributed. Again, what we come through is what's the mean? It's 5.8 days. Standard deviation, 1.8 days. Your graphing calculator following questions. Write your answers as in percent form. So over here we've got the percents. Round your answers to the nearest tenth of a percent. That's one decimal place. What is the probability of spending less than 9 days in recovery? So again, we come to the calculator. We have to reset the mean and standard deviation. The mean was 5.8. Standard deviation is 1.8. And we see our chart all set up for us. And then now we want, what is the probability of spending less than 9 days? Days are units, so that's in here. Less than 9 days, so this would be x is less than whatever value we put here. We can put the 9 days in there, and we see this. Here's 8 days. Yep, there's 9 days. Less than 9 days. That's a 96%. So remember, we multiply this by 100, so the decimal moves over 2. It's going to be 96.2%. Was the probability of spending more than 7 days in recovery? So more than, we change to going to the right, more than 7. And so we put our 7 as a boundary place, and we can see now it's more than 7, and here's 8, so it's a 7. It's going to be a 25.2%. Remember to move the decimal over 2 places, so that's 25.2. And then what's the probability of spending between these two values? Well, for us, we go to the tool that is the between. So the between two values, and our two values that we put in, 7 days and 9 days. That'll be a 21.5. We round up the 4 because of the 7. 21.5. Okay, I'm just going to submit this so it'll grade all of them, and we see green light is good. Okay, we can clear off all this marking now. So that's question 4. Question 5, we didn't spend a lot of time on this, but this is one of the things is you want to be able to determine if a distribution is normal or not. And one of the things is, there are some software that will print things out like this. So this is a cumulative probabilities. Right here's a percent. These are the data values. What needs to happen is, for a normal curve, is that these follow a line, and this is following kind of a curve. So this is not. We can conclude that this is not data from a normal distribution. If it was from a normal distribution, they will look like this, where you can draw a line that goes through most of them. So this one is from a normal distribution. Okay, so we'll submit those, and we see those are both correct. So it's just kind of knowing, if they give you a chart like this, it's a cumulative dot plot, that it needs to be along a straight line. Question 6. The average production cost for major movies is $67 million, and the standard deviation is 23 millions. Let's make it a little, it's less thick. Suppose that 17 randomly selected major movies are researched. So this is for just major movies in general. So this is going to be like a population value, all movies. This 17 randomly selected, that's going to be a sample value. Okay. Answer the following questions. Enter your answers in millions of dollars. Okay. What is the distribution of X? X is the population. So this is where this notation, the first number is the mean, the second number is a standard deviation. So for this one, we will enter in 67 for the mean and 23 for the standard deviation. Okay. What is the distribution of X bar? That's the sample. Now, if you remember from so this is from the sample, what we get is that it's going to have the same mean as a population, but the standard deviation, we have to go through a calculation, and that calculation, so actually let's go ahead and put the 67. It's always the means are the same, but remember the standard deviation is going to be the population standard deviation divided by the square root of the size of the sample. So there was 17 chosen. So this is what we're going to put in. Come over here and calculate that. We'll go up to our regular calculator, 23 divided by the square root of 17. So the sample will have a different standard deviation, 5.4 decimal places, 5.5783. Okay, and then now this we can answer basically question C and D in the same way. We are wanting to find the probability that a movie's production cost is between 64 and 66 million. So we go back to our distributions, but for the first distribution we're doing this for a single randomly selected movie. So we're going back to the population, just choosing something out of the population is what that means. So we put our population mean and standard deviation, so 67 and 23, and we want to find the probability that a number is between these two values. Lower value is 64, upper value is 66, and we get and there, notice there's no percent, so we're going to put in this decimal 0.0345. 0.0345, so 3.45%. Now when we come to the samples, the 70 movies in the sample, what we need to do is we need to go back and change 67 is still the mean, but the standard deviation is the 5.5783. 5.5783. We enter that one in, and now when we come over here, we want to get between, and we put in the same values, 64 and 66. 64 and 66. What we see is there's actually a larger percentage now. It's because we're dealing with the sample. So that will be 0.1335. So 13.35%. To answer this part, did you need to use the normality assumption for the central limit there? Yes, we did. And the reason is because they don't tell us the sample is normal, but we, from our exploration, we found that central limit theorem, that's what it says if you're pulling from a population, that the sample means will be normal as well. Okay, so let's submit that question. We got green all the way along, and so we're in good shape. And I think we have one or two more I think. This one's not so bad. It kind of goes back to just kind of the basics. Based on this, they give us a graph. What is the mean? The mean has to be here in the middle, so that's going to be 85. Standard deviation, so the way we get that is we can see here's 1, standard deviation 2, and then 3. So we just take the difference, take 94 minus 85. And that's going to give you 9. And that's our standard deviation. You could have taken 85 minus 76. You'll get the same value. All of this is 9. 94 plus 9 gives you 103, and so forth and so on. 68% of the data values are between which ones? This one you have to use the empirical rule, and you have to remember that one standard deviation above, one below to above, that this is going to be the 68% empirical part. From 67 to 103, that is going to be 95% of the data. That's 2 standard deviations, right? 1, 2. And then if we go 3 standard deviations, we'll come down here. That's going to get us the 99.7. And so we can enter these values of 76 to 94, 67 to 103, 58 to 112. Okay, and we'll submit it. And we got all green, so it's all correct. And our last question, we have population of values has a normal distribution. Mean of 80, standard deviation of 22.8. You intend to draw a random sample of size n equals 126. So this is going to ask about the sample, the mean of the distribution of the sample means. So remember the central limit theorem says that the means will be the same. So the population mean of 80 is also the mean of the samples. But the standard deviation sample means, and they want it to 2 decimal places, is going to be this 22.4 from the population, but this gets divided by the square root of the sample size, 126. Okay, and so we come over here, back to our calculator, 22.4 divided by square root 126. So it's going to be to 2 decimal places. No, the 5 is going to round the 9 goes up, and the 9 goes up, so it's going to be 2.00 to 2 decimal places. 2.00. Or just 2, right? 80. So those are all good. Put it in, we got it. And those are the 8 homework questions on the quiz. So sample questions, get working on the homework. You'll see similar questions, and you can go from there. Thanks.